Section 1.6 is titled Scatter Plots. A scatter plot shows the relationship between a set of data with two variables that are graphed as ordered pairs on a coordinate plane. So let's look at an example. Make a scatter plot of the approximate population of Tampa, Florida. And here in the table we see for a year what the population was in thousands. So for instance, if you look at the year 1960, the population in Tampa, Florida was 275,000. We need to make a scatter plot. So I'm going to take you to the next slide. We are going to let the horizontal axis or the x-axis represent the year. So down here I'm going to label year. We're going to let the vertical axis or the y-axis represent the population. So on this side, I'm going to write population. And remember, that was in thousands. So what we need to do first is label the units on our graph. So we're going to go back and look at the years that we need to be marking. We have 1940 to 2000. So I'm going to go by tens. We're going to go 2 out, and I'm going to say 1940. Here's 50, 60, 70, 80, 90, and 2000. Then the population, we need to see how we want to label the units on the left. So we see that it goes from 108 up to 303. So if I start at 100, I'm going to go by maybe 20s. Let's see if that'll fit on the graph. So if this is 100, I don't think 20s will fit. Let's go by 25s. So 125, 150, 175, 200, 225, 250, 275, 300, and 325. Now, when you make a scatter plot, you are graphing the ordered pairs as year in the x-coordinate here and population up on the y-axis. So the first ordered pair is 1940, 108. So we're going to go to 1940 and about estimate where 108 is. 1950 is 125. Oops. 1960 is 275. 1960, 275. 1970 is 278. 1980 we have 272. 1990 we're at 280. 'Oops, that one didn't stay on there, my 80. So 1990 again was 280. And then in 2000 we're at 303. So this is what a scatter plot looks like. You're just graphing ordered pairs. There are different types of scatter plots of the relationships. So we look at a positive relationship on the left, where as the x increases, the y increases. So you can see the data kind of trends upward. A negative relationship, as the x increases, the y decreases. So you can see a negative trend or a downward slope here. And if there's no relationship, then there's no obvious pattern to what happens with x and y. So here we have no obvious pattern. When you write this down, just kind of draw a quick little graph and make some plots and make it a positive relationship. For the negative, same thing, just make a quick little graph and show some data, and same with no relationship. So let's determine the relationship using positive, negative, or no relationship, and then we need to explain. So below we have a scatter plot of birth month and age of 22 people chosen at random. So you can see down at the bottom we have the month that people were born, and on the left, or on the y-axis, we have their age. So if we look at this data, if we look at the scatter plot, we're trying to determine if we see a positive, a negative, or no relationship. And hopefully here you can see no relationship. What this means is there is no relationship that can be drawn between someone's age and the month they were born. This data is kind of scattered all over the graph, so we say no relationship. Let's look at another example. Here we have a scatter plot of study time and test scores for 8 students. So we have study time across the bottom, and we have their scores on the left. And hopefully here you can see the data kind of starts to trend upward, so we have a positive relationship. And this should make sense. What this says is that the longer students study, as the study time increases, so do their test scores. And that should make sense. The more you study, or the more students study, oops. The higher they score on tests. So let's analyze some data. The table shows how many cups of coffee were sold during outdoor games at certain temperatures. So first you see the temperature row, and then the number of cups of coffee that are sold. First we want to make a scatter plot of the data. So across the bottom, I'm going to do temperature, and that's going to be in degrees Fahrenheit. And along the y-axis, we'll do cups of coffee. So if we go back, we need to look at the temperature. I see 34 as the lowest temperature, up to 75. So if we go back and we start at, let's go by 30. Let's go by threes, 30, 40, 50, 60, 70, and 80. And for cups of coffee, the lowest is 8, and the greatest is 42. So we need to go from at least 8 to 42. So if we start down here at 10, well, let's go by threes again. 10, 20, 30, 40, 50. And now we need to graph all of the ordered pairs. Notice I've done temperature along the bottom and cups of coffee on the right, or on the left. So the first is when the temperature is 34, the number of cups is 42. So 34 up to 42. And I'm just kind of estimating here. I don't exactly have every single temperature degree marked out. So I'm kind of estimating between 34 and 40. We have 36 and 39. We have 43 and 34. So 43 and 34. 45 and 33. 48 and 37. 54 and 18, 59 and 18, 62 and 13, 65 and 12, 71 and 9, 75 and 8. So there's a scatter plot of the data. We've just taken the two rows in the table and graphed them like they were ordered pairs. Now let's draw a conclusion about the type of relationship the data shows. So if we go back and look, hopefully you see a negative relationship here, that as the temperature increases, the cups of coffee are going to decrease. So we need to explain why that is. So this is a negative relationship. And you could say that exactly, that as the temperature increases, the number of cups of coffee sold decreases. And hopefully that makes sense to you. The warmer it is outside, probably fewer people want to drink coffee. Or the opposite side of that, the colder it is outside, more people want to drink coffee. And now we need to predict the number of cups sold if the temperature is 30 degrees. So if we go back and look at the graph, we need to go back to 30 degrees and up. So that's going to be somewhere on this line. And if our data were to trend in that direction, we maybe would be somewhere in here. And really there isn't an exact right answer. You could have a variety of answers here, but I'd maybe say somewhere between 45 and 50 cups of coffee. So now you've seen how to create a scatter plot given data and also how to analyze. We'll work on worksheet 1-6 in class.